Hello everyone, welcome back to ReMathable. First off, I want to apologize for the delay in uploading this video. I was a bit under the weather, and on top of that, I ran into some unexpected technical issues. But I'm back now and I'm excited to get started. Today, we're diving into the topic of sketching graphs of various functions. We'll take it step by step, tackling each type of function separately. Okay, so we'll start with linear functions, then move on to quadratic, followed by cubic, then reciprocal, and then finally exponential functions. So without further delay, let's dive right in. Okay, before we begin with the sketching, let's get one thing clear. What is the difference between sketching and drawing? Sketch versus draw. Okay, so for draw, you need to draw accurate graphs by plotting points on a number grid. Okay. Drawing entails accurate graphs Okay, if points do not lie in a straight line, we often join them with a smooth curve. Okay, if they lie in a straight line, then it's a linear graph. Otherwise, we join the points with a smooth curve. What about sketch? For sketch, you do not need an accurate drawing. Okay, you only need to show the shape of the graph. And you need to clearly indicate the location of the graph with reference to the x's. Okay? Location with reference. That's it. Okay? So in case of drawing, the graph needs to be absolutely accurate, while for sketching, just the basic shape and where it intersects the x's should be sufficient. Okay? Now let's begin with the most simple kind of function, linear function. How do we identify that a function is linear? Okay, it contains the term x. Okay, so the power of x is 1. The maximum power of x is 1. In that case, the equation will be linear. What do we mean by linear equations? Linear equations produce straight line graphs, okay? Which can be written in the form y is equals to mx plus c, where m is the slope or the gradient of the line and c is the y-intercept. What is the y-intercept? The point where the line crosses the y-axis, and that is the point where x is equals to 0. Okay, so this is a very quick recap of coordinate geometry. If you have any confusions regarding this, please have a look at the video which regarding the topic of coordinate geometry. Okay, I will explain all of this in detail there. But in this video, I'm just going to lightly touch upon it. Now, there are four possible kinds of lines that can exist. And what are the 4 kinds? Okay, so we can have vertical lines, we can have horizontal lines, we can have slanting lines. So these are the four possible scenarios that can occur in case of linear functions. Again, I'm not going to get into a lot of detail for this, but please revise the chapter of coordinate geometry in case you have any confusions. Okay, if you have a horizontal line, the equation of this line will always be in the form y is equals to a constant. A constant. Why is that? So for example, if y is equals to 3 here, right? So if this is 3, then the equation for this line will be y is equals to 3. Why? Because for different values of x, the value of y will always be 3. Okay? So the equation for a horizontal line is always in the form y is equals to a constant. Keeping the same logic in mind, the equation for a vertical line would be x is equals to a constant. So for example, if this is 3, then x is equals to 3 will be the equation of the line. Why? Because for different values of y, x is always 3. See. Okay? So these were two extreme cases where the line is either completely vertical or horizontal. Now, most of the time, the lines are sloping lines, slant lines, okay? Now, this is an upward sloping line. Why is it an upward sloping line? Because there are students who say that, this is a downward sloping line. So the rule here is that you have to read your graph from left to right, always. Okay, that is how you're going to read from left to right. So in that case, this is an upward sloping line. Left to right, this is a downward sloping line. Okay, the equation for these lines will always be in the form y is equals to mx plus c. Okay, so for sloping lines, the equation of line will always be in the form y is equals to mx plus c, where m is the slope, the steepness or the gradient of the line, and c is the y-intercept. Now let's very quickly discuss the gradients. In this case, the gradient will be positive. Why? Because it is an upward sloping line. As x increases, your y is also increasing. Okay, so the slope is positive. In case of downward sloping line, the slope is negative. Why? Because as the value of x increases, see, so the value of x is increasing, the value of y is decreasing. So it has a negative slope. What about this line? So basically, gradient is the steepness of the line, right? So this line is steep. Is this line more steep or this line? Obviously this one, right? This is the more steeper line. So as you move up, the line becomes steeper and steeper and steeper until it becomes vertical. This is the most steep line. Okay, the gradient in this case becomes, it is infinite. So it becomes undefined, right? And in this case, there is no steepness. It is flat, right out flat. So the gradient in this case is 0. Okay, and in case of vertical line, the gradient is undefined. Okay, now let's get to sketching. This was a quick recap of coordinate geometry. So if they give you a line, sketch y is equals to 2x plus 4. Okay, so what are you going to do? To sketch, you first need to draw your x's, y, and x. Okay, now you need to decide whether because it is in the form y is equals to mx plus c, Okay, so we know that it has a positive gradient, so the line will be upward sloping. So what we've determined the shape of our graph. It is going to be an upward sloping line. That's the first thing. Second, what is the y-intercept? This is the y-intercept, right? So the graph crosses the y-axis at 4. The third thing that you need to find is the x-intercept, the point where y is equals to 0, the point where the graph crosses the x-axis. So what are we going to do? This is our equation, y is equals to 2x plus 4. We're going to substitute y as 0 to find the x-intercept. X is equals to negative 2. So what is the point? Negative 2, 0. Let's plot these points very quickly. Negative 2, 0, this is 1 point. Crosses the y-axis at 4. Let's imagine this is 4. And we know it is an upward sloping line. So this is the sketch of the line. And we're going to label this line as well. Okay, so to sketch a linear equation, you first have to determine the shape, whether it's upward sloping, downward sloping, horizontal, or vertical. It's going to be one of the 4. Okay, that would be determined by the gradient. Then you're going to have a look at the y-intercept. Then you're going to evaluate the x-intercept, and you're going to plot the line and label it. Okay, that's how simple it is to sketch a linear graph. Okay, now let's start with quadratic functions. How do we identify quadratic functions? The maximum power of x is 2 in case of quadratic functions. So what is the general form of a quadratic equation? So y is equals to ax squared plus bx plus c. Okay, and if function notation is used, you should not be confused. The same thing can be written as this. F of x is equals to ax squared plus bx plus c. It's exactly the same as y is equals to ax squared plus bx plus c. Okay, they have exactly the same graphs. Okay, now the thing that you need to remember is that all quadratic curves produce curved graphs called parabolas. The parabolas are, so there are two possible shapes of quadratic graphs. A U-shaped graph and an inverted shaped graph. Okay, so both of them are known as parabolas. This is a U-shaped parabola and this is an inverted U. Okay, now a couple of important things that you should keep in mind. Firstly, parabolas have one line of symmetry. Okay, so one line of symmetry. What is the line of symmetry? A line that divides the curve or the shape into two exactly same overlapping parts. Okay, so see, the parabola would be divided in such a way. ठीक है, जो आपका टर्निंग पॉइंट होगा उधर से आपके ग्राफ को ये exactly two parts में divide कर सकता है. Okay, so the line of symmetry will always be on it will only always pass through the turning point of the parabola. Okay, however, there is no rotational symmetry. Why I'm mentioning these things here is because they were specified in the syllabus. So, symmetry, line of symmetry, rotational symmetry, roots, turning points, all of these are important terms and you need to know. What is a turning point? A turning point is basically the point where your graph, so for example, in this case, your y is decreasing, right? After the turning point, your y stops decreasing and starts increasing. See? So it turns. And in this case, the turning point is the minimum point of the graph, right? After this point, the graph starts increasing. Now, in the second case, your y is increasing, 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 and then comes the turning point. The point after which y stops increasing and starts decreasing. Okay, so there's a turn in the graph. And in this case, in case of an inverted U, the turning point is the maximum point. Okay, so no point on the graph is greater than this point. We will discuss them in a bit of detail, but I hope you understand what a minimum turning point is and what a maximum turning point is. Okay, so a minimum turning point is the point at the bottom of a parabola where the value of y stops decreasing and begins to increase, right? While a maximum turning point is the point at the top of the parabola where the value of y stops increasing and starts decreasing, right? And a parabola's minimum or maximum turning point is always on its line of symmetry, okay? So, turning point. A parabola's minimum or maximum turning point is always on its line of symmetry. Okay, so this is a maximum turning point and this is a minimum turning point. Okay, I hope the key terms are clear. Okay, now a parabola may contact the x-axis once, twice, or not at all. Okay, so what are the three possible cases? Let's see. Okay, so if we have, okay, see, one scenario, second, third, first, second, third. Okay, so see, in this case, the graph is intersecting the x-axis at 2 points. In this case, just at 1 point. It is tangent to the x-axis at this point. And in the third case, it is not intersecting the x-axis at all. This is in case of U-shaped parabolas. In case of inverted U, the three scenarios exist again. So in this case, it is intersecting the curve, the x-axis at 2 points. In the second scenario, it is just tangent to the x-axis, so it is in contact with the x-axis at only 1 point. And in this case, it is not intersecting the x-axis at all. Now, another important term that you need to keep in mind is that the points where a parabola contacts the x-axis are known as the roots of the equation. Okay, let's write this down. This is important. Okay, and also keep in mind that at this point, the function is equals to 0. Okay, the function is equal to 0. To find the x-intercept, we put the function equal to 0. So the points the points where a parabola contacts the x-axis show where the function or y is equal to 0. Okay, and the x coordinates of these points are called the roots of the function. Okay, so the word roots is also very important. You need to keep that in mind. Okay, roots are basically the values of x for which y is equals to 0. So it finds the x-intercepts. Okay, now one last thing before we try and sketch the graph of a quadratic function. You need to keep in mind that the graph will be U-shaped when the coefficient of x squared is positive. Positive x squared. Okay, so what is the coefficient of x squared? The coefficient of x squared is a. So if a is greater than 0, we will have a U-shaped parabola. Okay, and if the coefficient of x squared is negative, which means a is less than 0, we will have an inverted U. Okay, and our function will have a maximum value. I will repeat it. This is the coefficient of x squared. If it's positive, we will have a U-shaped graph, and our curve will have a minimum turning point. However, if the coefficient of x squared is negative, the graph will be an inverted U, and our graph will have a maximum point. Okay? Another thing to make note of is that the turning point and the line of symmetry, they are at the midpoints of the roots, exactly at the midpoints. Okay? Now, I'm also assuming and hoping that all of you are able to express a quadratic expression into completing square form, right? Because that is how we are going to find the minimum and maximum values of quadratic expressions. We find the maximum and minimum values, basically the turning points, the turning point of quadratic expressions by completing square, by completing the square. So what is the completing the square form? Okay, when you express your quadratic function in the form y is equals to a into x minus h squared plus k. So this is the completing square form, and I hope all of you recognize it and are also able to convert any quadratic expression into this form. If you have any confusions, then please comment and I will make a video explaining how we can achieve that. But in this video, I'm going to assume that you are perfectly capable of doing it on your own. So what is the turn? Once you've expressed the quadratic expression into completing square form, you need to figure out the turning point from this form. So it is this. Okay. So for the turning point, we are going to pick this number and change the sign. So it is negative h. So our turning point would be positive h, and we're going to pick the y coordinate as it is with the sign. So it's going to be k. Okay, let's do a couple of examples to ensure that you understand. So for example, if we have y is equals to x minus 2 square minus 3. Okay, so let's have a look. These are going to be the y coordinates of our turning points, and this with the opposite sign is going to be the x coordinates. So the turning point for the first equation is going to be 2, negative 3. So we're going to change the sign and use this as the x coordinate of the turning point. And in this case, we're going to use this as the y coordinate with the sign. Okay. In this case, we have a positive 1, so this will become a negative 1, positive 3. In the third case, negative 1 will become positive 1, and positive 3 would remain as positive 3. Okay, so these are the turning points for these quadratic expressions which have been converted into completing square form. Okay, so now we have all the key pieces of information. Now to sketch a quadratic function, you need to have these. You first need to determine the shape, whether it is a U-shaped curve or an inverted U. If the coefficient of x squared is positive, it is going to be U-shaped. X squared, coefficient of x here is positive. And if the coefficient of x squared is negative, we are going to have an inverted U-shaped graph. Okay, then the second step is where you need to find the y-intercept. How do you find that? By putting x is equals to 0 in the equation. Third, you need to find the roots or the x-intercepts. How do we do that? By putting y is equals to 0 in the equation or the function. The fourth step is to find the turning point. How do you do that? By converting your quadratic expression into completing the square form. Okay, and then you can, this isn't necessary always, but you can figure out the equation of the line of symmetry. What is it going to be? It's going to be a vertical line. What is the equation of a vertical line? It is in the form x is equals to a constant. And what is that constant going to be? It is going to be the x coordinate of the turning point. Okay, so this might seem a lot, but it isn't. Let's do one example to see how quickly we can sketch the graph. So for example, sketch the graph of y is equals to x squared minus 2x minus 8. Okay, so first step, The coefficient of x squared is positive. So our graph is going to be, the first thing is our graph is going to be U-shaped. Okay, second, what is the second step? We have to find the y-intercept. So we are going to put x is equals to 0. So our function becomes y is equals to 0 square minus 2 into 0 minus 8. So what is the point that is going to be on our graph? 0, negative 8. Third step, finding the roots, right? So the third step is to find the roots or the x-intercepts. For that, we're going to put y is equals to 0. So 2x squared minus 2x minus 8 is equals to 0. Let's do middle term breaking. Minus 4x plus 2x minus 8 is equals to 0. I hope all of us are extremely comfortable with middle term breaking and we have no problems in applying it. So x is equals to negative 2 or 4. So what are the 2 points on our graph? Negative 2, 0 and 4, 0. Okay, fourth step, the turning point. Fourth. For that, we're going to express our expression into completing square form. Okay, so x squared minus 2x minus 8, y is equals to x squared minus 2x plus 1 square minus 1 square minus 8. This would become x minus 1 whole square minus 1 minus 8, x squared minus 1 x minus 1 whole square minus 9. So what is our turning point going to be? So our turning point is going to be, it is going to be, since we have a negative 1 here, we're going to change the sign 1 and the second with the sign. So 1, negative 9. Okay, now we have all the key pieces of information and we can plot the graph. Okay, let's see. Let's just very quickly. So the first point is 0, negative 8. So you just mark a negative 8 here. We have negative 2, 0. Negative 2, 0 here. 4 should be double of negative 2. And our turning point is 1, negative 9. So it's going to be here somewhere. Negative 9 and 1. Okay. Now let's plot our graph. So it's going to be something like this. Okay, you have shown the key pieces of information, the point where it is crossing the x-axis, the point where it is crossing the y-axis, the turning point. All you're left with is to label this graph. Y is equals to x squared minus 2x minus 8. And they've not until and unless they ask you specifically for the equation of the line of symmetry, there's no need to mention it. But in this case, the line of symmetry is going to be wait, sorry. This, okay? Line which is crossing the x-axis at 1. X is equals to 1 is going to be the line of symmetry. So that's how simple it is to plot the graph, not to plot, to sketch the graph of a quadratic. Now on to the third type of functions. Third type of function is cubic. A lot of students are scared of this function, but it is a pretty straightforward and easy one, especially for the purposes of our syllabus. They've kept it pretty simple. So you should not be scared of it. Firstly, let's discuss how you're going to identify that it is a cubic function. So I hope the pattern is now clear. For linear, the maximum power of x in the function was 1. For quadratic functions, it was 2. And for cubic functions, the maximum power of x is going to be 3. Okay, so what is the general form of a cubic function? Is y is equals to a raised to the power a x raised to the power cube plus b x squared plus cx plus d. Okay, this can also be written as, in the function notation, exactly the same thing. Okay, same graphs, everything is going to be the same. It is just another way to write the same thing. Okay, this is basically the expanded form. Sometimes they will give you the quadratic function in factorized form. So for example, y is equals to x minus p into x plus q into x minus r. This is also a cubic function. Okay, because once you expand and you multiply, when x will be multiplied 3 times, you're going to get x cubed as the maximum power of x. Okay, another way to write a cubic function is y is equals to x minus p into ax squared plus bx plus c. Okay, the third way to write a cubic function is this. Okay, all of them will yield cubic functions. The graphs will be pretty similar when you're going to sketch them. So let's begin with the graph of the most simple cubic function, which is y is equals to x cubed. Okay, so the graph for this function would be okay. So this is how the graph of y is equals to x cubed looks like. Okay, and if the equation is y is equals to negative x cubed, if the coefficient of x cubed is negative, then our graph would look something like this. Wait. Something like this. Okay. Now all the other graphs or forms will be basically extensions of this graph. But before we get on further with complicated details, first learn to read this graph. So we always read our graphs from left to right, right? So what is this graph? It is a maximum and then a minimum graph, right? We did maximum minimum graphs in quadratic functions, right? So this looks like a maximum graph, and then this one looks like a minimum graph. So how do you read it? So you read this as a maximum minimum graph. And what about this one? The second one is going to be a minimum maximum curve, Okay, so now you need to memorize that for in cases where the coefficient of x cubed is positive, we will have a maximum minimum graph. Okay, and when the coefficient of x cubed is negative, we will have a minimum maximum graph. Okay, so memorize this so that you have no confusions when you're going to plot cubic functions. Okay, so whenever the coefficient of x cubed is positive, we're going to have a maximum minimum graph. With negative coefficients, we're going to have a minimum maximum graph. Okay, now let's delve into slight complications. Okay, so whenever you have to sketch the cubic function, what are the steps that you're going to follow? The first one is to determine the shape. Okay, whether it is a maximum minimum curve or a minimum maximum curve. Okay, we will have a maximum minimum curve when x cubed is positive, and we will have a minimum maximum curve when x cubed is negative. Okay, what is the second thing that you're going to find? The second thing that you're going to find is the y-intercept, which is basically what? That you have to put x is equals to 0 in the equation, and you need to find the value of y. Okay, the third step is going to be that you need to find the x-intercept or the roots of the equation. How do you find the x-intercept? By substituting or plugging y is equals to 0 and finding the value of, and it can also be values of x. Okay, so these are the 3 steps that we are going to follow. Before we apply these, I want to tell you the 3 possible scenarios of cubic functions. Okay, so the cubic function, there are 3 possible scenarios: that it crosses the x-axis at one point only, it crosses the x-axis at 2 points only, and it crosses the x-axis at 3 points. Okay, so where are the points? This is only one root, one x-intercept. In this case, it has two. Here it is just tangent to the x-axis. So we have 2 x-intercepts, and in this case we have 3 distinct intercepts. Okay, now the equations of the cubic graphs in each case are going to be, I'm going to write down the general form for each case. So when we just have one intercept, it is going to be in this form. Okay, so one root, one intercept, and this is a general quadratic expression or equation. Okay, in case the cubic function intersects the x-axis at 2 points, the equation is going to be in the form x minus b x minus q whole square. Okay, so this is going to yield 1 point, and the other point is this. So basically, I hope from quadratic sketching of quadratic functions, you're able to identify that this point is going to be P. Okay, this point is going to be P, this is going to be Q. Okay, P, Q, let's ignore the signs for a while. And for 3-intercept, it is going to have 3 distinct solutions or roots. So x minus P, x plus Q, x minus R. So this is P, Q, and R. Okay, I think it's best to just memorize or basically understand. Because it is intersecting the x-axis at one point, we're going to have one real root. Okay, and the second bracket entails a quadratic expression. In this case, it has 2 roots. So the first one is this is the first root, and the second root is the squares. So basically, we do not have 2 solutions, we just have one solution, which is going to satisfy this cubic function. And here, in this case, we have 3 distinct solutions. So the graph will cross the x-axis at 3 distinct points. Okay, let's do an example to put this knowledge to use. Okay, so sketch y is equals to x minus 2, x plus 3 into x minus 1. Okay, so first we need to determine, so these are the 3 steps, right? First we need to determine the shape, then the y-intercept, and then the x-intercept. So what is the shape going to be? Since this is not in the expanded form, we need to see for ourselves. So if this positive x will be multiplied with this positive x, and then this will be multiplied with this positive x, so positive into positive into positive is going to give you positive. So the coefficient of x cube is going to be positive. So what is our curve going to look like? A maximum minimum curve. Okay. Second step, finding y-intercept. To find the y-intercept, what do? We put x is equals to 0. Okay, so what do we have? Y is equals to negative 2 into 3 into negative 1. So y is equals to 3 into 2 is negative 6. Negative 6 into negative 1 is positive 6. So the graph crosses through 0 and 6. This is the y-intercept. What about the x-intercepts? So for x-intercept, we put y is equals to 0, okay? So x minus 2 into x plus 3 into x minus 1 is equals to 0. Now just like we do in quadratic, while solving quadratic equations, we're going to place each bracket equal to 0. Okay, and find the solution. So x minus 2 is equals to 0, or x plus 3 is equals to 0, or x minus 1 is equals to 0. Okay, so all the 3 brackets have been equated to 0 separately. So in this case, we're going to get x is equals to 2, x is equals to negative 3, x is equals to 1. So what are the points where the graph is going to cross your x-axis? So it's 2, negative 3, and 1. Okay, now we have all the important or key pieces of information. So we are going to now try and plot the graph. Okay, so here you go. The y-axis, the x-axis. So let's first place points where it's going to cross the y-axis, x-axis. So it's 1, it's 2, let's label 1, 2, and negative 3, is going to cross the x-axis at 6, and we know that it is a maximum minimum shaped curve. Okay, so see, let's first, okay, before sketching, always try and, pass through the points before actually drawing the curve, okay, so that you become comfortable. So do this a couple of times before actually drawing a line. Okay, so this is how our curve is going to be. This is a maximum minimum curve, okay? And to see that you can't plot it otherwise, it can't be a minimum maximum curve. Given the points that we've written, it's not possible to have a minimum maximum curve. So what is it going to be? It's going to be a maximum minimum curve. So a few tries and then you're going to sketch it, okay? Like this. यहाँ पे 2 कर लेते हैं, ठीक है? And then you're going to label your graph. So y is equals to x minus 2 into x plus 3 into x minus 1. Okay, so what are the key pieces of information? The x-intercept or the roots, and the y-intercept. And of course the shape, which is a maximum minimum. Okay, let's do another example, a very quick example. Sketch y is equals to x minus 1, x minus 2 square. Okay, so I hope you're able to recognize this form. It basically suggests that the cubic function or the cubic graph is going to cross the x-axis at 2 points only. Okay, but then let's just quickly follow the steps. First, we need to determine the shape of the graph. Okay, so let's see. So we need to see what the coefficient of x cubed is. Is it positive or negative? So x, positive x, and this is also positive, and even if it's squared, it will remain positive. So positive into positive is going to be positive. So x cubed is positive, so we are going to have a maximum minimum curve. Okay. Second, y-intercept. To find the y-intercept, we are going to place x is equals to 0 into the function. So what do we have? We have 0 minus 1, 0 minus 2 square. So negative 1 into minus 2 square, negative 1 into 4, so we have negative 4. Okay, so at x is equals to 0, y is negative 4. So this is the y-intercept. 0, negative 4 is the point. And the third thing that you had to evaluate was the x-intercepts, where you put y is equals to 0. Okay, so again, x minus 1 is equals to 0, or x minus 2 whole square is equals to 0. So in this case, x is equals to 1, or x minus 2 is equals to 0. We take the square to the other side, x is equals to 2. Okay, so what are the 2 points where the cubic graph is going to cross the x-axis? It's going to be 1 and 2. Okay, let's plot it. Okay, so y-axis, x-axis. Let's plot the point 0, negative 4. So negative 4 somewhere here, and 1 and 2. So 1, 2. Okay. Now let's see. It's a maximum minimum curve. So it's going to be, it's going to be something like this. Okay, so it's going to be tangent at this point and then some. Okay, so the graph has to be tangent as this point. Wait. Tangent and this. Oops. Okay, so what we can do is an easier way is to first draw your graph. Okay, and now you can label it. So this is 2, this is 1, and this is -4. Okay, it need not be very accurate. You just need to clearly mark the x and y intercepts. And once you place the numbers, there's no ambiguity left. Okay, and you also have to label this. Okay, so Kurt's cubic function is not a difficult function to sketch. You just need to memorize the shapes and then follow these 3 steps. Okay, I would also recommend that you keep these general forms in mind, as it would help you identify the number of roots that your cubic graph is going to have. Okay, now our 4th kind of function, reciprocal, also known as the rational function. Okay, again, please, I would suggest don't be scared of these functions. They're not tested in a lot of detail, so all that I think the examiner expects from you is to have a very basic knowledge of these functions, these reciprocal functions and cubic functions, exponential functions. Okay, so if you understand the gist of it, there's nothing to worry about. Okay, what are reciprocal functions? What does reciprocate means? When you divide by 1, right? Or you basically swap the numerator and the denominator when you reciprocate something, right? Similarly, the most basic form of reciprocal function is y is equals to 1 over x. Okay, now just like with the line, straight line, for straight line there were 4 possible scenarios, right? You could have a vertical line, a horizontal line, upward slanting or downward slanting. Okay, so for reciprocal functions, I'm going to jot down the 4 most basic shapes of the graphs. Okay, so let's first so this is okay, I will draw this myself. Okay, so this is for y is equals to 1 over x. Now if y is equals to -1 over x, what happens? Y is equals to -1 over x. These graphs, they change the quadrants. Okay, so this is in the first and the third quadrant. If we have a negative, our graphs would be in the in the second and the fourth quadrant. Okay, so these are the 2 possible scenarios. We're going to explore cases where we add a constant to this reciprocal function, and then our graph shifts up or down depending on the constant. Okay, but this is the basic shape. I would also recommend that you guys watch the video on asymptotes. I will share the link in the description. Okay. Before, I would recommend that before you, this is the video, okay? I will share the link of this video in the description. Okay, so before you get on with reciprocal and exponential functions, I would recommend that you watch this video because I'm not going to get into a lot of details for calculating the asymptotes here. It has been done in the video listed in the description, so please make sure that you go over it, understand it before you learn how to sketch graphs of reciprocal and exponential functions. Okay, but very quickly, the vertical asymptotes of a graph, we find them by equating the denominator equal to 0. Okay, so in this case, x is equals to 0. So this is going to be the vertical asymptote. And to find the horizontal asymptotes, we see what is being added or subtracted. So in this case, 0 is being added or subtracted, so your horizontal asymptote is going to be y is equals to 0. So this is your vertical asymptote, this is your horizontal asymptote. Okay, so whenever you have to sketch reciprocal functions, first find the asymptotes. Asymptotes are imaginary lines which the graph gets closer and closer to but never actually touches or crosses. Okay, so you're going to draw those imaginary lines on your sketch, and then you're going to draw your graphs, ensuring that they do not intersect or cross the asymptotes. Okay, so this was for rational functions. Now let's move on to squared rational functions or squared reciprocals. Okay, the general form or the most simple form is 1 is equals 1 divided by x squared. Okay, so the graph of such function would be of this shape. Okay, and I would suggest that you memorize it, but also understand why this is the shape of a squared reciprocal function. Okay, so for all the positive values of x, so for example 1, 2, it would become 1 over 4, for 3 it would become 1 over 9. This is how your graph is going to be. But if we substitute negative values of x, so for negative 1, square of a negative number is positive, right? So we will again have, so even for negative values of x, we will have positive y values, okay, because the square of a negative number is positive. So our graph is totally positive, all positive values of y. There's nothing for negative values of y, okay? But if we have y is equals to negative 1 over x squared. So basically, before I plot, understand, this will always yield a positive answer, always, right? As we have seen here. But then whatever your answer is, there's a negative out waiting for it. So all your y values, for all values of x, the y values will always be negative. Okay, so your graph would be okay. So you have no positive value of x here. your entire graph is in the negative y region. Why? Because 1 over x squared will always yield a positive answer. It can never yield a negative answer. So positive multiplied with negative is always negative. So all of the y values for this function will be negative. Okay, so I think you should memorize these 4 shapes, these 4 graphs, and also understand why we have such shapes. Okay, let's do an example. Sketch y is equals to 2 over x plus 1 negative 3. Okay, so this is a reciprocal function, but there's also constant added to it. There's something added in the denominator, and we have a value in the numerator. Okay, so I told you that the first thing that you have to do is identify the asymptotes. So for vertical asymptotes, what do? We put the denominator equal to 0. Okay, so the denominator in this case is x plus 1. So x is equals to negative 1. So this is the equation for your vertical asymptote. Why? Because if you place negative 1 in the denominator, negative 1 plus positive 1 is going to give us 0. So 2 divided by 0 is not possible. Division by 0 is not possible. And our function would become undefined at this point. Okay, therefore we have a vertical asymptote at x is equals to negative 1. Now let's find the horizontal asymptote. Horizontal asymptote is basically y is equals to a constant which is being added or subtracted in our function. So in this case it is negative 3. So y is equals to negative 3 is your horizontal asymptote. In case you have any confusions regarding this, please go and watch the video on asymptotes to clear any confusions. Okay, so now we have these. Let's plot these key pieces of information that we have identified. Okay, so our first, our vertical asymptote at x is equals to negative 1. So this one. And horizontal asymptote at y is equals to negative 3. So at this point. Okay? Okay. So this is negative 1. This is negative 3. Okay. Now, let's find, just like in normal graphs, we're going to find the x and y intercepts. Okay? To find the x-intercept, what do? We put y is equals to 0 in the function. Okay, so if we put y is equals to 0, x plus 1 minus 3, 0 is equals to 2 minus 3 into x plus 1, because we cannot carry out addition or subtraction of fractions until we have the same denominator, right? So we're going to multiply 3 with x plus 1. This is going to get multiplied with 0 and it will get eliminated. So 2 minus 3x minus 3 is equals to 0. 3x is equals to 2 minus 3, which is minus 1. X is equals to negative 1 over 3. Okay, so this point is going to be somewhere here. Okay, next we're going to find the y-intercept. To find the y-intercept, we're going to put x is equals to 0 in the function. So y is equals to 2 over 0 plus 1 minus 3 y is equals to 2 over 1 minus 3, y is equals to negative 1. Okay, so that is going to be here somewhere, negative 1. This is negative 1 over 3. Okay, so what have we done? First, we evaluated the vertical asymptote, then we found the horizontal asymptotes, followed by the x-intercept and the y-intercept. Okay, so because it is a reciprocal function, we know that it's going to be like this, right? Okay, I'm going to take this on the next page so that we can draw everything clearly. So we have a vertical asymptote at x is equals to negative 1, horizontal asymptote y is equals to negative 3, x-intercept x is equals to negative 1 over 3, y-intercept y is equals to negative 1, I think. Yes. And the equation is y is equals to 2 over x plus 1 minus 3. Okay, let's draw the graph with all the pieces of information that we have identified. Okay. So x is equals to negative 1 is going to be here somewhere. Okay. Y is equals to negative 3. Okay. So this is negative 1. Oops. Negative 1. This is negative 3. X-intercept of negative 1 over 3 here. And let's say negative 1 here. Okay, so what is our graph going to be? Since it cannot cross this and this, so the graph that we're going to have in the first quadrant is going to cross the x-axis at negative 1, y-axis at x-axis at negative 1 over 3, y-axis at negative 1. It's going to be something like this. Okay, so again, since it cannot touch or cross the asymptotes, it's going to be something like this. Let's draw it. So it's going to cross the x-axis at negative 1 over 3, y-axis at negative 1, and that's how it's going. So it's going to get closer and closer to the asymptote, but it's not going to touch it. Okay, and what is our other shape? So let's have a look at the graphs. So our other graph is going to be in the third quadrant. So what is the graph going to be? It's going to be here. Okay, if you have any confusions, you can plug in a couple of values in this function to check if you got the correct graph. Okay, so maybe you can place negative 2 in here, or let's do negative 3. Yes, let's do negative 3. So negative 2 over negative 3 plus 1 minus 3. So negative 2 over negative 2 minus 3, this will become 1. 1 minus 3 is negative. So it's 2 over negative 3 plus 1 minus 3. 2 over negative 2 minus 3, this will become negative 1 negative 3, so negative 4. Okay, so let's see. If x is equals to negative 3, somewhere here, we expect the function to be negative 4. So it is slightly below negative 3. So, okay. So similarly, if you're confused about anything, just place in a couple of random values to check if your graph makes sense. Okay. So you're going to plot your reciprocal functions in the same way. I'm going to do one example of squared reciprocals, and then we're going to move on to exponentials. Okay, so sketch y is equals to minus 1 over x plus 3 square minus 2. Okay, now what are the first steps? You need to identify the vertical asymptotes and the horizontal asymptotes. So for vertical asymptotes, we place the denominator equal to 0. So we have x is equals to negative 3. This is your vertical asymptote. For horizontal asymptotes, it is whatever is being added or subtracted to the function. So it is going to be y is equals to negative 2. Okay, let's draw whatever we know up till now. Okay, so we have a vertical asymptote at x is equals to negative 3. Okay, and a horizontal asymptote at y is equals to negative 2. So somewhere here. Okay, so these are our asymptotes, negative 3, negative 2. Okay, next, let's find the y-intercept. For y-intercept, we place x equals to 0, so we will have minus 1 over 0 plus 3 square minus 2, minus 1 over 9 minus 2, so we have minus 2 whole 1 over 9. So it's going to be here somewhere, right? And since it is a squared function with a negative sign preceding it, what shape is it going to be? This one. Okay, and we've evaluated our y-intercept as well, so it's going to be something like this. Okay, and you can recheck if you have any confusions, you think you've forgotten the shapes, you can plug in a few values of x to check if your graph is correct. Okay, so I hope that sketching of reciprocal or rational functions is clear after this. You will not be tested in a lot of detail or complex technical questions. You just need to have this basic knowledge of calculating the vertical and horizontal asymptotes. And I think if you memorize these 4 shapes, it's going to be sufficient to help you out for reciprocal functions and squared reciprocal functions. Okay, for reciprocal functions, for positive reciprocal functions, your graph will be in the first and the third quadrant. For reciprocal functions preceded by a negative sign, your graph is going to be in the second and the fourth quadrant. For squared reciprocal functions, if it is positive, it's going to be in the first and the fourth quadrant. If it is preceded by a negative sign, it's going to be in the second and the third quadrant. Okay, on to the final function, exponential. Okay, where your graph is in the form y is equals to a raised to the power x. Okay, now here you need to understand that the growth or exponential graphs can be growth graphs or decay graphs. Okay, we've covered this in the exponential and growth decay video. Please make sure that you've had a look at it, so that because it is a recently added topic, and I want all of you to be comfortable with it. I'm just trying. Yes, here it is. Okay, so this is the video that is on the channel, and please make sure that you've gone through this video and you understand this video. If you have any confusions, please feel free to leave a comment, and I will get back to you with all with solutions, or I will try my best to clear any confusions that you have. But again, this is an extremely important topic, recently added, so it has an extremely high chance of appearing in the exams this year. Okay, so I've discussed graphs in this video as well, but our growth graphs, so this is a growth graph. Okay, growth basically means that as you move from left to right, because that is how you read your graphs, your y increases. There's a growth in y. Okay, so the value of y is increasing as you move from left to right. As for decay, as you move from left to right, y decreases. So there is a decay. Okay, so the value of y is decreasing. Okay, so for exponential functions, sketching of exponential functions, exponential functions only have horizontal asymptotes. Okay, so you first need to identify those. How do we identify those? It is y is equals to the constant which is being added or subtracted to the function. Okay, then you're going to find the y-intercept. How are you going to do that? By placing x is equals to 0 in the function and finding the value of y. And that should be sufficient for you to draw your graph. Okay? Okay, so if they ask you to sketch y is equals to 2 raised to the power x plus 1. Okay, first step, what is the horizontal asymptote? It's going to be y is equals to plus 1. Okay, second step, finding the y-intercept. So you're going to put x is equals to 0 in the function, and what do you have? Y is equals to 2 raised to the power 0 plus 1. Anything raised to the power 0 is 1. Y is equals to 2. Okay, so let's now draw our exponential function with the key pieces of information that we have. The first one is a horizontal asymptote at y is equals to 1. Okay, so this is 1, and then we have our intercept at y is equals to 2. So your graph is going to be something like this. Okay, and you're going to label it as y is equals to 2x plus 1, x-axis, y-axis, and that's all. Okay, so to sketch an exponential function, you need to find the horizontal asymptote and the y-intercept, and then you should know whether it is a growth graph or a decay graph. Okay, The growth and decay basically depends on the value of A. Okay, if A is greater than 1, we will have a growth graph. If A is between 0 and 1, basically a fraction, it's going to be a decay graph. Okay, then you need to find the horizontal asymptotes, the y-intercept, and you just need to plot it and then label your graph. Okay, now I'm just going to practice a question from the practice paper and the specimen paper so that we can see how we can apply the rules learned here to the questions that you might face in the exams. Alright, so this is a function from the practice paper released by Cambridge from the topic of sketching. Okay, let's do it. So it is basically a 6-mark question and very easy 6 marks to score. Okay, factorize this cubic expression. Basically, this will help you complete part B later. Okay, so it just builds up. Let's take x common. Okay, so we will have 2x squared minus 3x minus 20. So now in the bracket we have a quadratic expression. We are going to solve it just like we solve quadratic equations. So we are going to do middle term breaking. So by multiplying 20 and 2, we get negative 40, and after adding or subtracting, it should be negative 3. So we can minus 8 and 5. Yes, so negative 8 into 5 is negative 40, and negative 8 plus 5 is negative 3. Okay, great. So x into 2x squared minus 8x minus plus 5x minus 20. Let's take 2x common, x minus 4 plus 5 into x minus 4, 2x plus 5 into x minus 4. Okay, so this is the answer to first part, and I think 3 very easy marks to score. Okay, now sketch the graph, write down the x coordinates of the point where the graph crosses the x-axis. So this is a must. Okay, how can we find the x-intercepts? By putting y is equals to 0 in the function. So basically, this is equals to 0. We've expressed this expression, we factorized it and expressed it in this form. So we're just simply going to place x into 2x plus 5 into x minus 4 is equals to 0. As we've learned this previously, we're going to place each bracket equal to 0 separately. So x is equals to 0, 2x plus 5 is equals to 0, x minus 4 is equals to 0. So here we have x is equals to negative 5 over 2 and x is equals to 4. So the graph crosses the x-axis at x is equals to 0, x is equals to 4, and x is equals to negative 5 over 2. Okay? And where does the graph crosses y-axis at? We're just going to place x. Okay, it's going to be 0. Because if we place 0 in place of x, so this term would be 0, this would be 0, and this would be 0. Okay, yes. So no y-intercept. It crosses the y-axis at 0. So, and because the coefficient of x cube is positive, it's going to be a maximum minimum curve like this, right? Since the x cube is positive, our graph is going to be a maximum minimum curve. So something like this. And you can just label it. I hope you have no problems in sketching or understanding this graph. These were 6 very easy marks that I hope everyone is going to achieve in their papers or were able to achieve when they were practicing this paper. And I hope that if you had any confusions, they've been cleared. Thank you so much for watching. I hope, really hope that this video helped you get a clear understanding of how to sketch graphs of different functions. Please remember that practice is the key. So keep working on these concepts and you'll definitely improve. With exams just around the corner, I really want to encourage you to stay focused and confident. Just believe in yourself. You've got this. If there's any topic you find confusing or want me to cover in a future video, please drop a comment below and I'm here to help you every step of the way. Okay? Also, if you found this video useful, please don't forget to like, subscribe, and share with anyone you think could benefit from it. Let's build a strong community where we all support each other in whatever we do. My prayers, my deepest, strongest prayers are with all of you, and I truly wish you the very, very best, not just in maths, but in every subject and everything that you do. Keep pushing forward and excel in your exams. Good luck. See you in the next video.